Hello dear students, I hope you all are fine and doing well in your studies. So students, so far in the chapter of sequences and series, we have discussed about arithmetic progression, arithmetic mean, geometric progression and then geometric mean. And now we are moving forward to take an important topic which is not only going to help you in this particular chapter, it is also going to help you in subsequent chapters. And the name of that topic is sum of special series. Or we can say that sum to n terms of some special series. And those special series are sum of first n natural numbers, sum of squares of first n natural numbers, and then sum of cubes of first n natural numbers. The results that we obtain from these series are used in most of the questions. So students, let's get started with studying about the series. So the special series that we are going to understand in this particular lecture will be important for this topic as well as for the coming topic in mathematics, because the results that are being derived over here are used wherever required. Alright, so let me introduce you first with the special series that we are going to learn. The first series is sum of first n natural numbers. So the sum of first n natural numbers is denoted by sigma r, where r lies from 1 to n. Alright, you must be familiar with this sigma notation, which indicates the continued sum. So now if I substitute r equals to 1, then 2, then 3 till n, we are going to get the series 1 plus 2 plus 3 plus 4 till n. So this is sum of first n natural numbers, also denoted by this sigma. Alright, and the result of this series is equal to n into n plus 1 divided by 2, which means that the sum of first n natural numbers is always equal to n into n plus 1 by 2. This is the result of this sigma. Alright, for example, if we have to add first 10 natural numbers, so the sum of first 10 natural numbers will simply be equal to 10 into 10 plus 1 divided by 2, which is equal to 5 into 11, which is 55. And in sigma notation, we can write it down as sigma r, where r lies from 1 to 10. So the maximum value of n is 10. So we have applied the formula n into n plus 1 by 2 in order to get the answer very quickly. Once you memorize the sum of first n natural numbers formula, you are not supposed to add all of them one by one. You can simply put the value of n over here in order to get the answer. Alright, this second special series is sum of squares of first n natural numbers. So now we are required to find the sum of squares of, that is 1 square plus 2 square plus 3 square. This goes on till n square, and this series can be written in sigma notation as sigma c, 1 square, 2 square, 3 square. So we can write r square, and r is varying from 1 to n. So sigma r square is equal to this series where r is lying from 1 to n, and its result is equal to n multiplied by n plus 1 multiplied by 2n plus 1 whole divided by 6. For example, if you have to add 1 square, 2 square, 3 square and 4 square, so this is going to be 4 into 4 plus 1 into 2 times 4 plus 1, which is 9 divided by 6. Alright, so this becomes equal to 30. Upon calculation, this comes out to be equal to 30. Alright, so this is simply based on the application of this formula when we were required to find the sum of squares of first 4 natural numbers. So the value of n becomes 4. So we have substituted n as 4 over here. This becomes 4, this is 5, and this becomes 9. Whole divided by 6 will give us the final answer as 30. Alright, so you have to memorize the sum of first n natural numbers and sum of squares of first n natural numbers along with their sigma notation. The third series that we are going to understand is sum of cubes of first n natural numbers. So again we have cubes of first n natural numbers and then we have to add them up. So we are going to get 1 cube plus 2 cube plus 3 cube and so on. This goes on till n cube. And now I hope you can write down this sigma notation as sigma r cube, where r lies from 1 to n. And result of this series is just the square of result of this series. Alright, so square of this is going to be what? N square n plus 1 whole square divided by 4. So suppose that you have to calculate 1 cube plus 2 cube plus 3 cube plus 4 cube plus 5 cube. So the value of n goes till 5. So we are going to substitute value of n as 5 in this form, in this result. So we are going to get 5 square into 5 plus 1 ka square, which is 6 square divided by 4. Alright, so according to these special series, we can reduce our time in determining the sum of first n natural numbers or sum of squares of first n natural numbers or sum of cubes of first n natural numbers. And then we can find out the sum of various series which are based on these results. Alright students, so I hope everybody must have understood so far. Now we are going to prove each one of these results because it is very important to understand their derivation also. So let us begin with the first series, that is sum of first n natural numbers. So sigma r equals to 1 से n तक is given as n plus 1 by. So sigma r means 1 plus 2 plus 3 till n. Now one can easily see that this is just an arithmetic progression. This is an AP whose first term is 1, nth term is n, or this can also be written as last term, and the common difference in this arithmetic progression is of 1 unit. So this sum of n terms of an arithmetic progression is given by n by 2 a plus an or l. Alright, if we know the first term and last term of an arithmetic progression along with their common difference, so the sum can be written as n by 2 multiplied by a plus l. So this becomes n by 2 and a is what? 1 and l is what? N. So simply this is proved that n by 2 into n plus 1 is the sum of first n natural numbers. Alright, so I hope that this was very simple from my side and even from your side in understanding that sum of first n natural numbers is given by n by 2 into n plus 1 or n into n plus 1 by 2. In either way you can memorize. Let's move further and understand the proof of sigma r square, r lying from 1 to n, and this is equal to n plus 1 to n plus 1 whole divided by 6. Now for this we are going to use an identity that a cube minus b cube is equal to a minus b multiplied by a square plus ab plus b square. Alright, so if I substitute A as r and B as r minus 1, so this becomes r cube minus r minus 1 whole cube, and in RHS we can write r minus 1 along with r square plus r into r minus 1 plus r minus 1 whole square. Alright, I have just plugged in the values of A as r and B as r minus 1 in this identity, so we have arrived till here. Now let's simplify a bit. So we have r cube minus r minus 1 whole cube equal to, this bracket becomes equal to 1, so we are required to solve this one. This is r square plus r square minus r plus this is r square minus 2r plus 1. So this can be further written as 3r square, r square, r square, r square becomes 3r square, minus r minus 2r becomes minus 3r and plus 1. So in all we have r cube minus r minus 1 whole cube as 3r square minus 3r plus 1. Now we are going to substitute the values of r from 1 till n. So if I substitute r equals to 1, this becomes 1 cube minus 0 cube is equal to 3 into 1 square minus 3 into 1 plus 1. Alright, now if we suppose that r equals to 2, so this becomes 2 cube over here minus this becomes 1 cube is equal to 3 into 2 square minus 3 into 2 plus 1. Now if we substitute r equals to 3 in this identity, we get 3 cube minus 2 cube equals to 3 into 3 square minus 3 into 3 plus 1. And we can continue this till r equals to n. So when r equals to n is substituted in this identity, it becomes n cube minus n minus 1 whole cube. This is equal to 3 n square minus 3 n plus 1. Alright students, I hope everybody is getting till this point. Now in order to prove this particular series summation, we have to just add all the terms in LHS as well as in the RHS. So if we add all the terms in the LHS, what is going to happen? When I add them up, 1 cube gets cancelled off with minus 1 cube, 2 cube gets cancelled off with minus 2 cube, and this continues till the cancellation of this minus n minus 1 whole cube. Alright, so in LHS, upon addition, we are left with n cube minus 0 cube, which is 0, and in RHS we have to add all these terms also. So over here I can take 3 as common, and then we have 1 square plus 2 square plus 3 square till n square, and over here I can take minus 3 as common, and we have 1 plus 2 plus 3 till n, and over here 1 is added n times, which gives us simply n. Alright, so far so good. So we have n cube equals to 3 into, now this becomes what? This becomes sigma r square, where r lies from 1 to n, minus 3 times. This is sum of first n natural numbers. So sum of first n natural numbers is already known to us. This is n into n plus 1 divided by 2 plus n. Alright, now we are required to find the value of this sigma summation r square from r is equal to 1 to n. So I am going to take this term in LHS and this term as well in LHS. So we are going to get n cube plus 3n n plus 1 whole divided by 2 minus n is equal to 3 times sigma r square. Alright, so upon calculation in LHS, we are going to get n plus 1, 2n plus 1 divided by 2. Alright, we have to just simplify the LHS, take n as common from these three terms, and there will be a quadratic in n. Upon factorization, it would give us n plus 1, 2n plus 1 as factors. So this combined can be written as n plus 1, 2n plus 1 divided by 2. Alright, and over here we have a 3 sigma r square. So now if I transpose this 3 over here, it gets divided in the denominator, and the denominator becomes 2 multiplied by 3, which is equal to 6. So we are done with proving that sigma r square is going to be equal to n into n plus 1 into 2n plus 1 whole divided by 6. So our series is proved that this summation will give us this result. Alright students, I hope you are comfortable enough along with me in proving this series. Let's move further and prove our third series, which is sigma r cube. R equals to 1 to n, and this is equal to n square, n plus 1 whole square divided by 4. Alright, so see, in sigma r square, we had taken the identity n cube minus n minus 1 whole cube, or r cube minus r minus 1 whole cube. Alright, so in this sigma r cube, we are going to take the identity of a raised to the power 4 minus b raised to the power 4. And this is a square minus b square multiplied by a square plus b square. Alright, now we are going to put a as r and b as r minus 1, which gives us r raised to the power 4 minus r minus 1 raised to the power 4, as over here we can have r square minus r minus 1 whole square multiplied by r square plus r minus 1 whole square. Alright, so again over here we can apply a square minus b square identity. So this gives us a minus b, which is equal to 1, and a plus b, which is equal to 2r minus 1. And here we can write down r square plus r square minus 2r plus 1. So this is 2r minus 1 multiplied by 2r square minus 2r plus 1. Alright, now multiply each and every term so that we can get 4r cube minus 4r square plus 2r minus 2r square plus 2r minus 1. So in all, we are going to get a cubic in r, which is 4r cube minus 6r square plus 4r minus 1. So r raised to the power 4 minus r minus 1 raised to the power 4 can be written like this. Alright, now again we have to keep substituting the values of r from 1 to n. So if I substitute r equals to 1, this becomes 1 raised to the power 4 minus 0 raised to the power 4 equals to 4 into 1 cube minus 6 into 1 square plus 4 into 1 minus 1. Now you must be wondering, why am I not calculating this trivial calculation? Because we are going to add them up upon writing each and every term. That is why I am not interested in calculation over here. Alright, now suppose that r is equal to 2. We get 2 raised to the power 4 minus 1 raised to the power 4 equals to 4 into 2 cube minus 6 multiplied 2 square plus 4 into 2 minus 1. R equals to 3 raised to the power 4 minus 2 raised to the power 4 equals to 4 into 3 raised to the power 3 minus 6 into 3 square plus 4 into 3 minus 1. Alright, and upon continuing till r equals to n, this becomes n raised to the power 4 minus n minus 1 raised to the power 4 equals to 4 n cube minus 6 n square plus 4n and minus 1. Alright, so in this identity, students, we have substituted the values of r from 1 to n, and now since we are interested in determining the sum of the series, so we are going to add all these terms in LHS as well as in RHS. So upon addition, what happens? These terms gets cancelled off. So what we are left with is n raised to the power 4 minus 0, which is 0 itself, and this is equal to summation over here will give us 4 and then 1 cube plus 2 cube plus 3 cube till n cube. So this can be written as sigma r cube, r is equal to 1 to n, minus 6 taken as common, and we have 1 square plus 2 square plus 3 square till n square, which is sigma r square, and sigma r square is now known to us. This is n into n plus 1 into 2n plus 1 divided by 6, plus 4 will be taken as common from these terms, and we are left with 1 plus 2 plus 3 till n, which is sum of first n natural number, and it is also known to us as n plus 1 divided by 2, and 1 added n times or minus 1 added n times will give us minus n. Alright, so now we are just left with the simplification part. Take this term in LHS, this term also in LHS, and this also in LHS. So we can have n raised to the power 4 plus n plus 1 into 2n plus 1. This 6 gets cancelled off, and over here we can have a factor of 2 in numerator, which becomes minus 2 times n into n plus 1, and this minus n comes over here in the form of plus n is equal to sigma r cube, r equals to 1 to n, and this 4 when transposed over here, this gets divided and comes in the denominator. So now we are needed to simplify this expression, and upon simplification we are going to get n plus 1 divided by 2 whole square, which is equal to n square n plus 1 whole square divided by 4. So we are done with proving this series sigma r cube as equal to n square n plus 1 ka whole square divided by 4. Alright, so students, I hope you all must have understood these three special series, sigma r square and sigma r cube, that is sum of first n natural numbers, sum of squares of first n natural numbers, and sum of cubes of first n natural numbers, and you must have understood their proofs also. Now you are supposed to remember these important results so that we can solve the questions based on it in our coming lectures. So students, this is it for today's lecture. In our next lecture, we will be discussing the questions that are based on some of these special series. Alright, see you in the next lecture. This is it for today. Thank you.